Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, the moderator for today's event, and I welcome you. We have a great webinar on tap for you, but before we get things rolling, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, just know you'll be able to access the webinar on demand. You'll be receiving a link after the webinar that will take you to the webinar. And we are actually answering questions from the audience. So if you have a question for our panelists at any time during the event, just use your GoToWebinar control panel and submit your questions. And we'll take a few minutes near the end of the presentation to go over the audience questions. Okay, with that, we'll go ahead and jump into today's webinar, which is managing and monitoring multiple teams on Red Hat OpenShift. Our speakers today are Samuel Van Dam, Lead Product Specialist at Coscale, and Ed Seymour, Business Development Manager at Red Hat OpenShift. Welcome, gentlemen. Thanks for joining me today.
It's great to be here.
Hi, thank you, Charlene.
Great. Well, Ed, I'm going to go ahead and turn it over to you and let you do your thing.
Brilliant, thank you very much. Right, hi everybody. So today we're going to be talking about managing and monitoring multiple teams on Red Hat OpenShift and backed by alerting and monitoring with Coscale. So my name's Ed Seymour. I'm a specialist in containers, Kubernetes and OpenShift at Red Hat. And so what I wanted to do today is initially sort of talk about some of the challenges that maybe you're having around containers. So if you imagine if you may be getting your applications and starting to put them into containers, and you find that by doing this, putting in these containers, you're able to encapsulate everything that you need to be able to run that application, and you'll see then you have this great portability across different platforms and environments. And essentially what becomes present with these containerized applications is that from an operational perspective, if your ops team know how to run those containers, you're not having to navigate all the different types of technologies and things like that that you both are dealing with. So essentially what the container can do is become this single unit of currency between development and application operations. However, if you're doing anything that's more than just a simple, trivial application running on its own, then we can see some additional challenges then around how to rerun those. So how do we create an application that we run at scale, that we're connecting with lots of other applications, that maybe is leveraging persistence and storage in particular ways that would be very difficult if we're just dealing with single containers. So this is where Kubernetes can help us. Kubernetes provides an abstraction across for our underlying infrastructure, but unlike things like infrastructure as a service, which provides great automation for infrastructure components like virtual machines and storage and networking, Kubernetes is designed from an application perspective. So the abstraction works from those app perspectives. So when I'm creating applications, I'm able to essentially transpose those logical designs of how I create an application, connect it with other applications, and transpose that into Kubernetes resources and be able to run and manage my applications. So Kubernetes provides you with this fantastic mechanism for building those applications. What OpenShift is essentially a Kubernetes distribution for enterprises. So when you build an OpenShift environment, what you're essentially doing is building a certified Kubernetes system backed by Red Hat knowledge, support, and expertise around running applications in a secure and managed way. So essentially, you build an OpenShift environment on top of Red Hat Enterprise Linux or Enterprise Linux solution. You get the OpenShift includes everything that you need to be able to build and manage that Kubernetes environment. We augment Kubernetes to include telemetry, and we provide it so that it's pre-configured for storage and security, that networking is all sorted out and available for you. And then we provide you with additional capabilities and tools on top of that to make interacting with Kubernetes straightforward and simple and easy to use. And then included with that, we will then provide you with additional support and capabilities for container images that you might want to run it. And if you wanted to leverage Red Hat's middleware, so things like JBoss EAP or other capabilities, middleware features, then we're providing those as add-on subscriptions that you'll be able to leverage them within that OpenShift environment and be able to get secure and supported containers that you can then just simply drop in your applications into that. So if you say, for instance, had an existing Java EE application, you'd be able to drop that on top of our JBoss EAP container to get a containerized version of your JE application within the certified to run in our platform. OpenShift is fully open source, and if you look upstream to the OpenShift Origin project, that is the upstream open source community project that essentially is collating all of those upstream projects and working with those upstream projects to create that distribution of Kubernetes. So when you get an OpenShift subscription, you're essentially getting a cherry-picked version of that OpenShift Origin. We typically run about a month behind the upstream, a release behind the upstream Kubernetes release. So Kubernetes is currently on 1.10, OpenShift is currently on 3.9, so that's mapping to a 1.9 version of Kubernetes. And the reason that we do that is that when the new Kubernetes distribution drops and is released, Red Hat engineers will be working to resolve any bugs and do all of the testing to create that enterprise distribution. What you find is that, what we typically find is around about 100 bugs or so that we would patch and fix during that release life cycle, getting to the point where we would do our next release of OpenShift. If you're not aware of the way that Red Hat work in terms of patches and fixes, we always patch upstream. So if we find issues and bugs with something like Kubernetes, all of those get pushed upstream. We patch upstream first, and then we backport that into the distribution that we're providing. So the ultimate the intention is to provide fully supported and patched and updated distributions of the system as a product through the OpenShift container platform. We also have an open user group called OpenShift Commons. We have many hundreds of companies that have joined OpenShift Commons. It's free to join it. It's a really good resource for sharing information with other users of OpenShift and looking at how they're using OpenShift with them. And it spans corporations that are using OpenShift in their own environments, that are building their own OpenShift environments, partners that are providing OpenShift capable or OpenShift backed services to their customers, or ISVs that may be using it to package their applications. So an example of that would be Coscale, who we're running this webinar with today. And so I'll hand over to Samuel now, who's going to talk a little bit about what Coscale brings.
Okay, thanks, Ed. So hi, everyone. I'm Samuel Van Dam. I'm a lead product specialist at Coscale, and my main job revolves around helping customers monitor their OpenShift environments. Now, for the people that don't know Coscale yet, Coscale is a full stack performance monitoring tool specifically built to monitor container or microservice environments. What we see a lot at our customers is that OpenShift is an amazing product, but it's a lot more dynamic and scalable compared to the more traditional environments. And from a monitoring point of view, this is of course a challenge. Now, the tool we provide is really built for OpenShift, and we really provide a first-class support for the entire OpenShift infrastructure and tool. We also support a wide range of other technologies like Ed mentioned JBoss and Spring Boot and all these other technologies you can find in these container environments. We're an OpenShift Prime partner. Coscale is really built to be lightweight, non-intrusive, easy to use, and I'll show you during the webinar and during the demo a little bit why that is. Now, we do a little bit more than just gather data. So Coscale also has an integrated anomaly detection system, and for people who are unfamiliar with anomaly detection, pretty much you can boil it down to we try to find abnormal behavior in your environment. And really this is very powerful in production environments. If you can think of an average environment has around 3,000 metrics per node, the anomaly detection will watch them all and let you know when they behave in a way they haven't before. Now, what's a little bit new, and this is also the reason why we wanted to do this webinar together with Red Hat, is that we released a very powerful role-based access system. But we'll demo that a little bit later. Let me quickly show you first what Coscale gathers in terms of data, so you know that also. So the first layer that we gather, can you go to the next slide, Ed? Thanks. So the first layer is, of course, that we gather data from the clouds, and pretty much we will integrate with Azure, AWS, Google Cloud, and a lot of the other providers, which are more public clouds, but we also integrate with private clouds. On top of those clouds are then, of course, your servers themselves and the nodes. From there, we get a lot of data like any other monitoring tool. So the basics, CPU, how much CPU is being used, how much memory is available, how is the storage capacity, and so on. Now, where we're a little bit unique already is that we also gather a lot of data from OpenShift itself. So we built a very tightly coupled integration with the orchestrator, with OpenShift, that gets data on the services, the projects, the applications, and so that's really the next layer in this story. And during the demo, we'll really show you how this helps in looking at your monitoring data. And this OpenShift integration also allows us to then do very cool stuff once you go to multiple teams on one cluster. Now, of course, on top of OpenShift are then the containers. From there, we also get a lot of resource data, CPU, memory, storage, quotas, and so on. And then within the container, of course, you have your applications. Now, Coscale has built a lot of integrations for web services, databases, caching tools. And we look at a lot at Red Hat OpenShift for that, what are they using, so that our customers can get the most insight into their containers as possible. And this is all built in a container native way. And what we understand by that is that it's easy to set up. You don't need to install an agent in the container or even add a sidecar. Coscale is just one container you deploy on each node, and it scales also together with your environment. So if you go from running your application once to running it 100 times, Coscale will be able to pick that up and start to monitor each and every instance of your application. The last layer is then real user monitoring. What we see a lot of at our customers is that usually a web application is developed, and with that real user monitoring, we want to monitor that end result, really your user experience, your page load time, request, errors. And besides that, I really also want to say is that this is not everything. So Coscale is really a platform you can build on. So there's a lot of ways to custom integrate with us. We have open APIs. And so pretty much everything that our customers want to build, we can do. And we really love to help with that. Now I know Ed wants to talk a little bit more about the OpenShift layer and specifically the namespaces, so I'm going to give the word back to him.
Thank you, Samuel. Okay, so if you're not familiar with Kubernetes, that when you are running applications in Kubernetes and you have these container images, you don't run a bare container. What you do is you run these containers in what are called pods within Kubernetes. And so what a pod does is it provides the running container with a kind of surrogate host. It doesn't lock you to a specific underlying infrastructure. And it gives the container runtime its own IP address, so we can address the IP address of that running pod and be able to talk to that container. So it gives us that flexibility to have those containers running within the environment without being locked to a specific host, like you would if you were just running a single container. And we also have something called services. So services provide then a stable endpoint that are DNS resolvable and discoverable, so we can talk to a service to be able to then talk to our pods. So that enables us to be able to rapidly scale up our applications and not be limited, to having to manually manage things like load balancing and stuff like that within the application. So there's a lot more to Kubernetes than that, but that kind of gives you a kind of the basics, the pod and the service, basically the basic infrastructure for your applications within Kubernetes. Now the namespace within Kubernetes enables us to basically take the resources for our running applications that define our running applications, both the containers and the pods and the things that are going to run, the description of how we run our application, and namespace them within that Kubernetes environment. And that enables us to be able to isolate different versions, perhaps, of our application, or even work with different teams. Now, in a straightforward Kubernetes environment, if you wanted to do something clever with that, you would need to extend it and configure your Kubernetes platform to do it. What OpenShift does is it extends that namespace and enables us to attach it's the point of attachment for our multi-tenancy within an OpenShift environment. So you have things like role-based access controls. You're able to set quotas and runtime limits for the applications within that. The project and the namespace provide a place to create and store your containers and manage accessibility to container images. So if you want to use OpenShift to build containers, which is very popular, then you've got somewhere for those containers to essentially live. And then it also provides the mechanism for the isolation around the software-defined network. So if we had multiple applications running on the platform with multiple tenants, then you're not going to get accidental connection between apps that are running in different namespaces. So it gives you that network isolation within the environment as well. Okay, so I think now we're going to move over to the demo, and what I'm going to do is hand over to Sam, who's going to demonstrate an integrated version of Coscale that's connected to an OpenShift environment that we built. Just a little bit of notes on the OpenShift environment that we created. So OpenShift, you can deploy OpenShift in many different configurations. It's quite flexible, and you can essentially run it anywhere that you can run Red Hat Enterprise Linux. We would provide that would be a supported platform for OpenShift. So that could be on-premise on physical servers, it could be on virtual machines, it could be on private cloud, or indeed, as we've done here, it's on the public cloud. So what we've done is we've used Amazon, we've used 3 availability zones, and I've created a highly available platform that sits across those 3 availability zones that I have. I think I've used the island region for this. In total, I have 9 nodes. I've divided those nodes into different roles. So I have nodes which are managing the master services. So this is the OpenShift data store, the API, the scheduling, the DNS, that kind of thing is on those master nodes. Then we have 3 nodes which are dedicated for infrastructure components. So there we're running things like OpenShift logging. It's the internal metrics that are built into OpenShift. We're running container native storage, so actually got storage running within the platform, and various other bits and pieces as well. And then finally, we have 3 other nodes which we are running, which are the home for the applications that we're going to build on there. And to make this a non-trivial example, so rather than have like an empty environment, I created 20 users, and then for each of those users, we created 3 projects. So they have 3 projects each, and in those projects, they're running a set of JE applications and connecting to a MySQL database. So we've got some load on the platform that we'll be able to see. So once I'd set up the platform, I then followed the instructions for installing Coscale on the platform. So what the Coscale agents do is that they essentially connect and collect metrics for OpenShift and then send it to the Coscale software as a service provision. And that's what Samuel will be showing us in a minute. What I would say is that actually installing that took about 5 minutes at most. It's very straightforward to install and add that to the platform. So it was a really good experience actually working with that. Okay, so what I'm going to do now is hand over to Samuel. Go.
Okay, thanks, Ed. And great to hear you had a good experience with the installation. So thanks a lot for the description of the environment. What you see now on your screen is the Coscale application or the Coscale platform. Now Ed has followed the installation instructions for Coscale, and what you see then is here all these nodes that he has provided for the demo today. They're all being monitored by Coscale, and these numbers then signify the applications that are being monitored. To give you a quick idea on the installation instructions, depending on the version of OpenShift that you use, we create a security context, we create a project for ourselves, and then we deploy as a replication controller and as a daemon set. And the big advantage of that is, of course, that if you scale up your environment, if you change nodes, if you make changes in your cluster, Coscale will automatically be deployed on those machines. As Ed mentioned, Coscale will gather data, send it through around every minute, and you can then use that data in dashboards and in our alerting system. And here's one of our default dashboards. So this is the OpenShift cluster overview. Gives you a high level view on your cluster, how many containers, nodes, namespaces or projects. You can see number of pods per node, and then some events coming from the environment. So we look at the events of the things that are happening with the Kubernetes of OpenShift, the pods that are created, and so on. And as mentioned before, we gather a lot of data. So what you will find a lot in Coscale is drill down systems. So for example, these nodes, I can actually go to a dashboard that then shows me detailed information from the nodes that are available. And you can already pick out the ones that are the application nodes. You can see these 3 have a lot of containers running on them. And on each of these, you can then see how much of the CPU and so is used, which containers are using the most CPU, how many containers were started and stopped in this time range in the last 24 hours. And I can even filter. So for example, if I want to see just the containers running for the dev demo 1 project inside OpenShift, I can select that and I can see they're all running on this node, which is maybe not ideal because if that node goes down, I will be losing my application. Now, this is just one of the views. So we also have our replication controllers view, which shows then more of the services within OpenShift. So these are the applications that were deployed. I can see if there are problems with these applications. So in this case, there was some too few replicas for the prod demo 1. Again, I can filter and zoom in just to that. You can see those 3 services that are defined. So the Monster Blue, green, and then the MySQL. And then again, the idea is that you can click through, and I can click on this to see a more detailed view of the data. So you can see now the performance data coming from that container, which is a MySQL container. And actually, if I zoom in a little bit more, I'll explain what this is a little bit later. I can see nicely now on which host it's running, what the image is, which ports are defined, all the environment variables. We filter those out that might be sensitive, and I see CPU usage over time and so on. And again, I can click through and actually I have set up application performance monitoring for this application for the MySQL, so I can nicely see some MySQL metrics. If I take one step back, now the way we do this is really with the integration in OpenShift. So you saw me open this dropdown, and this is something we call a dimension. And you can see it a lot in other tools. Sometimes it's called tags, sometimes it's called labels. And here you have the namespaces group. And pretty much these are all the projects that were defined in the OpenShift environment. So it becomes very easy to say, okay, I want to compare those 4 projects. I want to have the sum of all the resources they use, and click apply. It now calculates in the backend all that data, so it can take some time. And this way I can see, okay, which project is actually using the most CPU. It's not a lot, but it's using 0.04. And then the system allows you then to actually go and research, okay, within that project, what do I have? I have deployment configs, replication controllers, and so on. And okay, let's take a look. Let's take a look at those deployments that have happened. And then I get, again, the data, but just for those deployments. So it seems green is using the most. And you can keep drilling down. And so, sorry, green was the biggest one. So you can see there were 3 deployments for green, and then I can actually take a look at all the pods running for those deployments, and this should give us a pretty interesting graph, and where you can see that all these deployments happening and the data being stopped and then new data coming in and so on. So this is really something we can do thanks to that integration with OpenShift, and sort of some really cool stuff to show. Ed, I'm going to give the word back to you so we can take a look at that.
Okay, thank you, Sam. Okay, so what I'm going to do now is show you some things going on in OpenShift. So I've got a couple of users on OpenShift, so I'll just log in to this one here. So I've got a couple of windows open. And so this user is logging in, and so they can see there's a catalog, so they can get creating with applications straight away. They have a list of projects here, so the project's mapping to Kubernetes namespace, and I can click through to that project. And then within that project, I can see that I actually have something already deployed. So I have a little app running in here, just very basic. It just creates a map of the world. So we're running that app within that environment. Okay. So if I go back to this other login here, so this is the same system. So I'll log in as user 1 in this one. I can log in to this system, and in this environment, it's a clean environment. I have not got any projects or I haven't set anything up in this particular one. So what I want to do is initially with this user is to create a project. So I'm going to call this my app DEF. So we create that. And once I've created that project, you see that I have my list of projects. I just have my project available in it. If we go back to this project, list all the projects, I only have one project listed. So if I go into this project, nothing in it. Let's go and create something very quickly. I'll just do an example. So there's a Hello World application based on Node.js. So if I just sample, just clicking all the defaults here, just to go ahead and create that. And then once I've created that, this will go ahead and create my application for me. So essentially what I've just done is I gave OpenShift a link to a Git repository with some example source code in it. And I told it to marry that with our Node.js container. And it's created a build configuration to build me a new container image from that. It ran all of the npm commands needed to run that, created a brand new container image, and then pushed that to the OpenShift registry, which is what's just happening there. So we're just pushing the layers to the registry. Once it's pushed those layers to that registry, we'll be able to, it will deploy that application, and we should see that application start up. While it's doing that, there we go, it's just going to start a deployment in a minute. While it's doing that, I'll go back to this project here for the other guy. Just zoom that in a little bit. And we've decided that we want to collaborate between these two teams. So I'm going to go to the membership here, and at the moment, user 2 is the admin for this project. So you can see that we've also got groups and something called service accounts, which I'll go into in a little bit. So in this instance, what I want to do is just use a user. So we'll say, let's make user 1, let's give user 1 an edit role on that project. So done editing. Oops, forgot to click. User 1, edit role. Add that user. Okay, so user 1 now is an edit on that, has got edit role on that project. And if I go back to this project, our app should be working, so that's great. Here is our application. Welcome to your Node.js application OpenShift. That's good. And you know what? I'm going to do the same thing here. So I'm going to go to membership for this project, edit the membership. I'm going to make user 2 and give them an edit role on this project. There we go. So now if I look at my projects, my list of projects, I can now see that the second project has appeared. And similarly with this user 2, if they look, then they can see that the DEF project has appeared. Okay, so in this DEF project, we just created a container image. And wouldn't it be great if I could actually pull that container image onto my command line? So if I go to my command line, I'd actually logged in at the command line. I'm using the OC tool here to log in as this user. And so if I get my projects, we should see my project being listed. Here it is. So I'm going to set my default project to my DEF. Okay, now, so if I do get pods, that's going to show me my pod that's running. There we go. So we ran a pod to do the build, which is completed, and we also have a pod which is running, which is our application that's running at the moment. Now to run that, we're actually using an image, a container image, and we represent a container image in OpenShift using something called an image stream. So if I do OC get image stream, we'll see that I have essentially a pull specification for that container image being listed using that image stream. Now that pull spec, if you may notice that the service name there is an internal Kubernetes service, so that's not externally available. But actually what we do have is we have made that container registry externally available as well. So I should be able to do a Docker pull on that container image using this. Registry apps OpenShift.red is the name of the registry, and then that is the container image. Let's make that a little wider so it's not wrapping around. And I want the latest version. Okay, so this is going to try and pull it. But as soon as I try and do this, I get an authentication required message. So I'm not authorized to pull that image. Okay, so going back to my OC command, what I could do is do a Docker login and pass the token that I have for my user. So if I do OC who am I and get -T, it will show me my user's token. But this token is temporary and it's not something I really want to use to log in to an external system. Really what I want to have is a service account that I can use. So ideally what the approach that I would take is to create a service account, and I'm going to call this Docker Puller in my project. So I'm just going to go ahead and do that. And that service account has got a token which I can use then for authentication. So let's say Docker Puller. We'll see. So it's a bit like a private key. So this service account, and actually they should be treated like that, because this is going to give you, through this key, I'm going to be able to give people access to my services within this environment. So now if I do a little bit of bash with that to just save that into a variable, equals that. Oops. I should then be able to do a Docker login. I'm going to call this Docker Puller, and the password is that token, and it's at registry apps OpenShift.red. There we go. I get a little warning, but basically login has succeeded. Okay, so now can I do a Docker pull? There we go, Docker pull. So I try and do the Docker pull again, and we're now able to get that. By default, our service account is given has been given the rights to pull images from my namespace. And so now I'm able. Now it's pulled this container. It'll be pulling it into my local container image registry, and I'll be able to manage it. But if I was using anything else to manage containers or move containers between different environments, then this is one of the techniques that I might use. There are other tools like things like Scopio, which enable you to copy containers from one registry to another registry, so we might want to use that. And actually, while you're using Scopio, you can also actually get it to sign your images as well. So it basically will pull the image, sign it, and then push it back into another registry for you. Okay, and so with that, I'm going to hand now back to Sam.
Okay, thanks, Ed. That looks really cool. Now, the question we get asked a lot then is, you have this very powerful permission system within OpenShift. You can give people access to certain parts of their data, and of course it makes sense in multi-tenant environments. As a developer, you don't need to see, and maybe you don't even want to see the data from all the other teams. The only thing that matters is that the service runs well. And we've had the same question a lot also in Coscale. We have a lot of service providers or very big OpenShift deployments. And because we gather so much data, it can get overwhelming for a customer. To be able to fix that, to be able to limit the amount of data a customer can see, we've added RBAC. And the way you find it in our tool is through limited roles. pretty much a limited role. It's just name, could be application A or team A. And then you select which servers, groups, or namespaces they have access to. So for example, in OpenShift environments, it becomes very easy to say, okay, I want to create a team, and this is the, let's say the dev team. They have access to all the dev environments. Now, I've already created a user beforehand, so you can see application XYZ. It has access to dev demo 1 and a couple of others inside Coscale and OpenShift project, sorry, and I've added the user to it. Now, if I open an incognito browser, you can see I've already added the user, and I'm just going to log in. What you will see is that this user has a lot less on his screen. And if we quickly compare it to the full view, and you can see he gets his servers, he gets his metrics. And when I actually go on the servers page, you will see that he only sees a couple of things, and pretty much those are the groups I selected. So you can see the dev demo 1 and my app A and C. And this is then only, well, he will only get data from these servers or containers within his dashboards, and he will only see data from the applications that are also within those namespaces. So that means if I go to the MySQL dashboard, for example, I will only be able to select the MySQLs that are linked to those projects. And the same then, for example, for Jalokia, because OpenShift has a lot of the time, or sorry, the OpenShift source to image images, a lot of the time I have a Jalokia enabled. I can then nicely see those. So this becomes a very powerful system once you go to very large environments or where you want to give your customer access to certain parts of the data. Now, a question we sometimes get asked is, okay, but what about a network level? And I know Ed is going to show a little bit talking about network isolation, and I'm going to give it back to him then to show off that cool feature.
That's brilliant. Thank you, Sam. Okay, so what I've done here is we have our two projects, and I've just shown you a bit more information about the applications that we've got running. So we've got this Node.js application that's running, and we've got this Mapit application that's running. And what I've done is I've asked OpenShift to give me the IP addresses of those those pods that are running. And what I wanted to show here was the network isolation. So within the scope of these applications, so they're running in two separate namespaces. If I open up a shell terminal, which I can do here at the command line, I can actually also do it in the web browser as well. And then if I attempt to curl that IP address of the Mapit application, and what I'm going to do is just say on port 8080 because that's what the application is listening on. So if I attempt to do that, what I'll see is it's attempting to connect to that, but it's actually not successful. And the reason for that is that what we're doing is by default we're adding a network. There is by default there's network isolation between those namespaces. So I'm just going to log in as the user 2 because that user. Oops. Got to exit the shell. Log in as the user 2, and as user 2, I'm going to just change my configuration in my project. So I'm going to go to my project, my app, XYZ. And what we have in the project, in this particular deployment, we're allowing the project administrators to manage their network connectivity. Now, you might decide that you don't want to do that, so you could remove this capability. But if we look at something called a network policy, we'll see that we actually have network policies configured already within the environment. So I have some allow so ingress policies that allow a connection from other namespaces. So I'm going to do here is I've already got this YAML document here, which describes an example network policy, which is going to say allow communication from a namespace which is labeled name myapp.def, which is where the other application is running. So if I now use that to create the network policy, this will then open up that project. So now if I go back to my project, myapp.def, and get the pods in that project, and let's rerun that test again. So just opening a remote shell, I just copy the IP address. And now if I do a curl, what I'm going to do is do -i so that we don't see the HTML, we just see the header and the IP address and then port 8080. So now when we run that, we immediately get that response. And so essentially what I've done is I've opened up that project and enabled us to be able to communicate with the containers that are running within that project. Now what I've done is actually opened up every port, everything within that. What we could do is we could actually restrict that to say you're only able to communicate on very specific ports, and we can do other restrictions as well. Okay. The next thing I wanted to do was show a little bit around the way that the quotas are working. So in our projects that we have, we are running our applications, and as we created these new projects, we automatically applied quotas to the system. So the platform administrator, which was me in this case, had gone and predefined some quotas and limits that get applied to the projects when they get created automatically. And so here we have the quota, that we get quota on the CPU and memory, so the number of cores that are available. The request is what we expect our applications to use by default. And then limit is what we allow to the team to peak above that request amount. So request is supposed to be where they should be normally, and then limit is they should not go above that amount. So that's the limit there. So both these amounts, and then we have values for other things. So there shouldn't be more than 15 pods, for example. There are other limits that we've got that were scoped differently. We've got quotas on the number of configuration maps, persistent volume claims, the amount of storage that can be allocated. All of that, these are the total amount of resources that can be applied within the project. When I look at the limit constrain what I can do for any specific container. So in this instance here, any container that's running, I cannot use more than 1 core per container. So whereas I may be able to allocate 4 cores in total for my project, I can't allocate any more than 2 cores in this example to any specific container within my project. Okay. As a way of carving up that the quotas that we apply to our project. And I can show you this sort of running an example of this. So if I very quickly go out to my projects and I create a new project, let's call it load test. There we go. And what I'm going to do in the command line is I'm going to create a new app. So I'm going to use this OC run command, and the OC run command is basically going to pull a container in and create a deployment configuration for it. What did I call that project? Load test, right? Load test. So I'm going to go ahead and create that within that project. And what I'm doing is saying here, use the image Docker.io CentOS, so just a CentOS container from Docker.io, and I'm going to say run this command, the dd command, if dev 0 of dev null. If you're familiar, what that normally do, it would basically use one core up to its maximum. So you'd normally see 250%, sorry, 100% CPU utilization in that container. So let's do, I get my pods. There we go. So we have, oops, switch to that project and get the pods. All right, so now I have this container running. Now the other thing that I did here is I added a limit in. So I overrode the default, which was I think 1 core, and I said use a CPU of 250 M. M stands for millicores. What a millicore is a thousandth of a CPU. So the millicore gives us the ability to basically take a container, take a core, and then divide it down into parts. Let's just see that here. If I look at the resource limits, here it is through the web UI. So what this millicore is doing is the 250. What we should see is about 25% CPU utilization. I shouldn't see more than 25%. So let's have a look at my container. So again, I'm going to create a shell into that container. So if I do a PS within the container to see what processes are running, because we're running in a containered environment, I'm only seeing the processes running within my container. And we can see there's our dd command that's running. And then if I run the top command within that container, we should see there it is after it settles down. Our dd command is running at approximately 25% CPU utilization. Okay. Right, so I think that's me. I'm going to hand back now to Sam.
Okay, thanks, Ed. So the quota system is a really powerful system, especially if you're going to, again, large environments or environments where you have customers, a lot of customers sharing the same servers, because it means you can limit at least the pods, and that means that one pod cannot overtake your system. When talking to customers, we noticed a couple of, well, I wouldn't say issues, but problems with it is that when you ask a developer how much CPU his application needs, and I used to be a developer, my response would be pretty high. I would say 2 gigs at least. But when then running that application in production, it turns out that a lot of the times you don't need that much. So we were seeing a lot of times at customers that their cluster was not used in the most efficient way. A lot of the resources were requested, but not actually used. So we decided then we needed a view for this, and that's what you're now seeing on your screen. So this is from a node point of view. We're showing for each node how many cores are used and how many cores are requested and how many cores are available in total. And here already we see a little bit that case where 0.2 cores are used, but 1.5 are requested. So that means in this case 1.3 or 1.29 is not being used, but still is not available to your system. With Coscale, you can then drill down, see which pods are requesting that, and then together with the developers as an operations, you can fine tune that, meaning that you're using your environment as efficiently as possible. This, by the way, can also be alerted on, so all this data can be used to proactively send you an email when that is the case. We have the same system also available for namespaces, so for projects, so a little bit of data that Ed showed us. And you can see here all the different projects that are defined in OpenShift, and then each time the limits that they have, and then how much of that limit they're currently, using, how many pods and so on. And this is all on a time range, so you can see how projects evolve over time if they start to use more of their system. And this is really, again, you can alert on this and see be notified when a project is getting very close to its limit, so you can react to it beforehand instead of after it becomes a problem. Now, there is still a lot more to show in terms of Coscale, and the same, of course, goes to OpenShift. But I'm going to give the word back now to Ed to summarize a little bit what we've shown you today.
Super, thank you, Samuel. I don't have anything to show on my screen now. I think that's essentially the end of the demo today. So essentially what we've shown today is sort of some of the ways that you're able to manage multiple teams within an OpenShift and Coscale environment, and how you're able to kind of manage and monitor and those platforms. So currently today, Coscale is available to be integrated with OpenShift Container Platform. So Container Platform is the self-managed version of OpenShift, the OpenShift distribution that you can then build and deploy yourself in these different environments. So I hand back to Charlene, so we see if we have any questions.
Yeah, sure. Okay, so great presentation, guys. We do have a couple questions when we're nearing the top of the hour, so I think we'll be able to get to one or two of them, but whatever we don't get to online, I'm sure these guys will be able to follow up with you post-event. We have a question here from Raphael who asks, does Coscale aim to do some kind of deep dive monitoring or instrumentation excuse me, on JVM-based apps on top of OpenShift?
So yeah, that's a very good question. So we will be able to get data from Jalokia, and we even have specific integrations built for Spring Boot, for JBoss, for a lot of the other stuff. And we can provide, for example, insight in the latency of requests that are being responded to. So we have a pretty good insight into what the application is doing. The next big story, or the story for us this year, is tracing, being able to go almost inside the application and seeing what's happening there. I have to say that one of the big goals of Coscale is to be as lightweight as possible. So everything we build, we have to make a little bit of the trade-off. Okay, we can gather that information, but it has an impact. So do we want to? And that's something we do a lot. If you're interested in a more detailed view on what we can get for all the applications in OpenShift, especially JVM based, I would love to give you a demo at a later time. But thanks again for the question.
All right, great. Okay, one more question from Kevin, who asks, my biggest problem is trying to find solutions that will run on the dedicated environment. Can Coscale be deployed and fully give all functionality on the dedicated platform?
So yeah, that's also a good question. And actually, we were doing some discussion in the background around that. And it's indeed, so Coscale is deployed as a privileged container. And so in a lot of times it would depend on Red Hat to allow us to do that. So at the moment, I don't think it's possible, but we'd love to see and discuss with the people from Red Hat and maybe with Ed to see if we can get that use case working. But we'll contact you definitely after the webinar and see what we can do for that. Okay,
great. Well, let's see. Do we have time for one more? Yeah, let's see. Now, I think we're going to go ahead and wrap it up now since we do have 1 minute left. I do want to thank everybody who did submit questions. And as I said before, if we didn't get to your question during the event, these guys will be more than happy to contact you afterwards and get your answer. Get the answer to your question. Also, a reminder to our audience that today's event has been recorded. So if you missed any or all of the event, you will be receiving an email with a link to the webinar on demand. The webinar is also going to be living on the devops.com website. So if you don't get that link or you lose it or whatever, it's not working for you, just go to the devops.com website and click on the webinar section. We have a slew of webinars there on demand and upcoming. So you should be able to find that one, plus hopefully at least one or two or three or four that also pique your interest. I would like to once again thank our presenters today, Sam Van Dam and Ed Seymour. Thanks to you both for joining me today. It was a great webinar. And I would like to thank the audience for joining me today. And everybody, I hope you have a great day. This is Charlene O'Hanlon signing off.